All right. So just a quick announcement. Next week, Friday, is our first test. Remember, everything that's going to be on test one is in our test one folder on Blackboard. For test one, the material will go up to like this Friday. So anything next week, unless I say something on Friday, like we have a little bit to catch up on, but generally anything next week won't appear on test one. Test one will be given online over Blackboard, and I'll put up some more information about the exact procedure and how to access the test here later on in the week. But yeah, just so you're aware, next week, Friday, is our first test. So just to catch us up where we were on last Friday, we began to look at our amino acids. We saw how our amino acids came together to form a peptide. And then we started with this idea of the idea of the charges of amino acids change based on pHs. And this idea about PI, where it's a pH, where either an amino acid or a protein as a whole is neutral charge. So what we're going to work on for a good chunk today is we're going to see how at different pHs we can predict the overall charge of a peptide. So that's what we're going to work on. I have 4 problems for you and one that will work together where we'll try to figure out what is the charge of the peptide team at a pH of 1, 7, and 14. All right, so some things that'll make this easier for us. We should know what amino acids are charged at a pH of 7. So at a pH of 7, and this is something that you're going to want to commit to memory because usually we always work at a pH of 7. But anyways, the ones that are charged at a pH of 7, negatively charged are D and E. Positively charged are A, K, and roughly like 40% of the time, H. So histidine, 40% of the time is positively charged at a pH of 7. Roughly 60% of the time it's not. So it switches. All right. So let's figure out what the overall charge of team is at pH 1, 7, and 14. So what I'm going to do is I'm just going to rewrite our peptide. So there's team. Don't forget that every peptide has an N terminus and a C terminus, right? Okay. Now, after I've written the peptide, what I like to do is I like to write the pKa underneath my amino acids. So I'm going to draw another line that says pKa. The pKa of all N termini is 9. We're going to say it's 9. It changes. It does change in actuality. If you look on the sheet I posted on Blackboard, you should see that the N termini do change. But we're just going to say all N termini have a pKa of 9. T-threonine, the side chain doesn't have a pKa, so I'm going to put an X there. Glutamic acid, E, has a pKa of 4.25. Alanine does not have a pKa, so I'm going to put an X there. Methionine does not have a pKa, so I'm going to put an X there. And the C terminus, we're going to say all C termini have a pKa of 2. So all I've done so far is write the pKa's of my termini and my amino acids. All right. So at a pH of 7, let's determine the charges. Well, luckily for a pH of 7, we should have this more or less memorized. So RK and N termini are all charged at 7. DE and all C termini are negatively charged at 7. So the charge of team at 7, the N-terminus has a positive charge. Threonine is neutral. Glutamic acid has a negative charge. Alanine is neutral. Methionine is neutral. C termini has a negative charge. Overall, the charge of this peptide at a pH of 7 is -1. All I did there was add up the charges. So pH of 7 is easy if you know what's positively charged and what's negatively charged. All right, let's figure out what the charge of this amino acid is at a pH of 1. Now remember, when it comes to pHs, the lower the number, the higher the proton concentration. So the lower you go in pH, the more protons you have. And here's a little trick that I've learned to do over the years. I don't know if it's going to be useful to everybody. Some people seem to like it, but this is how I keep it in my, keep the protonation states in my head. All right, so let's start with the N-terminus. And all I'm going to do is I'm going to write the pKa, I'm going to write the pH of 7, and the pH that the problem's asking for, and I'm going to write them in order from big at top, small at the bottom. Now, we always care about, or we've learned our amino acids at a pH of 7. So when doing these problems, I always find that thinking about a pH of 7 is my like my home base. So at a pH of 7, I'm positively charged. So I'm asking myself, what happens to the N-terminus if I go from a pH of 7 to a pH of 1? Now, the rules of this system is, if I go from a pH of 7 to my target pH, which in this case is 1, and I never pass pKa, that is, my pKa is not between 7 and 1. Therefore, my charge stays the same. So I went from a pH of 7 to a pH of 1. My pK is not between 7 and 1, so I don't do anything to my N-terminus. My N-terminus remains charged or protonated. T doesn't have a pKa, so T, no matter what pH we go to, between 1 and 14 will never change. So T is always neutral. All right, so that's N-term. Now we have our next amino acid that has a pKa, glutamic acid. So glue. So I'm going to do the same thing. I'm going to write pH of 7, it's pKa, and the pH that the problem's asking for, all in order. And I'm always going to start at 7. That's my home base. And at 7, we're negative. Now, if you see when I make my arrow, I go from 7 to 1. I cross my pK. That is, at a pH of 7, I'm higher than my pKa. At a pH of 1, I'm lower than my pKa. When this happens, when I start above my pKa and I go below my pKa, like in this problem, I gain a hydrogen. Yay. So in this game, when I make a move like that, start above the pK and go below the pK, I gain a hydrogen. Hydrogens have a positive 1 charge. Therefore, if I have a negative 1 charge at a pH of 7, when I go to a pH of 1, I'm now neutral. So at a pH of 1, glutamic acid is neutral. Alanine doesn't have a pKa. I don't care about it. Always neutral. Methionine doesn't have a pKa. Don't care about it. Always neutral. C-terminus. I'm going to do the same layout. So pH of 7, pKa, and my target pH, all in order. I start at 7. I go to whatever pH the problem asks for. My pKa is between these two numbers. So at 7, I was negative. Since my pKa is between these two numbers, I gain a proton. Proton's positively charged. I go to neutral. Neutral. So overall, at a pH of 1, the peptide team has a positive 1 charge. Now let's do pH of 14. And if you weren't quite following along on a pH of 1, maybe seeing it again at pH of 14 will reinforce it. So pH of 14. So I'm going to do the same thing. N-terminus. And I'm going to write everything in order. So I always start at pH of 7, then pKa of 9. And my pH, the question's asking for, is 14. So for the N-terminus, which is positive at 7, going to 14, now I start below my pKa and I go above my pKa. Here I lose a hydrogen because remember, at high pHs, the amount of protons available are low. So that means we lose protons. So I lost a proton going from a pH of 7 to pH of 14. Makes the N-terminus neutral. T doesn't have a pKa. I don't care about it. T will never change. E, they do the same thing. pH of 14, pH of 7. Oops, 7, not 17. pH, or pKa now, of 4.25. So list the pH 7, pH of the problem, and pKa all in numerical order. I always start at 7 because 7 is my home base, and I go to the pH of the problem. Here, for glutamic acid, the pKa is not between 7 and 14, so it doesn't change. As long as my arrow doesn't pass the pKa, the charge never changes from what it was at 7. So at a pH 14, 7 is still negative, or E is still negative. Alanine, no pKa, doesn't change. Methionine, no pKa, doesn't change. C-terminus, pH of 14, pH of 7, pKa 2. Start at 7, go to 14. Never pass my pKa, so it stays negative. It stays what it was at 7. So overall, the charge of the peptide team at a pH of 14 is -2. So that's the system I use to determine what is the charge of any peptide at any pH. Some things to keep in mind with this, and I wrote down the side. The lower in pH you go, the more likely you are to be protonated. The higher in pH you go, the more likely you are to lose a proton. The pKa is what's determining when you gain or what you lose when you lose a proton. And that's why I write it in order like I did on the right. All right. So you've seen the system that I use. Is there any questions that people have right off the bat of how I did team? Well, if not, or if you do, you can continue to type. But let's see if you can figure out the charges of ARCHI and glyglupro-trip-asp and asparagine, phenylalanine, and glutamine, arginine, and alanine, and this picture I have below. So we're going to take a good amount of time today, see if you can work these out. I'm going to give you time to do this before I actually answer them, so you can get your hands dirty. I'll leave this writing up here for you to try and follow along. But if you have questions, please let me know. If you have an answer and you want to check with me, feel free to let me know as well. Otherwise, I'll let you get to it. All right, so hopefully you had some time to at least try Archie. So let me go through Archie. So we can make sure we're all on the same page. So I'm going to write all this and do ARCY. AREKY. Okay. Whoops. Hey, let me erase that. EKY. ARCY. First thing first, I'm going to write the pKa's. So 9 doesn't have one. R is 12.5. E is 4.25. K is 10.75. Y is 10. And the C terminus is 2. So Y is one of the weird ones where it's not charged, but it does have a pKa. So pKa of 7, or pH of 7 rather. So this is how we learned the amino acid. So hopefully over time, this will just become intuitive to you. N terminus always charged at 7. Only is neutral. R is positively charged. E is negatively charged. K is positively charged. Y is neutral. C terminus is negatively charged. So if I count that up, should have overall a +1 charge. All right, pH of 1. So I'm going to do the same game. For the N terminus, pKa 9, pH 7, pH 1. Never pass, so the charge stays the same. A doesn't have pKa, so that will never change. R, so pKa of 12.5, pH of 7, pH of 1. Never goes past pKa, so it will stay the same as was in 7. E, pH 7, pKa 4.25, pH 1. Passes, so loses, or sorry, it gains a proton when it goes below it. So E becomes neutral. K can do the same thing. It'll say positive. Y, I'll do that one. Stays neutral. And then the C terminus is going to be just like glutamic acid, where it's 2. So it will go to neutral. And let me just make little bars so we can follow this easier. So at a pH of 1, we are at a +3. Basically, at low pHs, everything that's negative becomes neutral, right? pH of 14. So at a pH of 14, N terminus. So a pH of 7, pH of pK of 9, pH of 14. Go above it, and we lose a proton. So everything that's positive at 7 becomes neutral at 14. So I'm just going to do that for the positives. So neutral, neutral, neutral. A doesn't change. If you're negative at 7, you're going to say negative at 14, following the same rules. Now let's get the Y. Y is going to be a little bit of a special case here, right? So pH of 7, pKa of 10, pH of 14. So we go to 7 to 14. We go above the pKa, so we lose a proton. Remember, a proton has a +1 charge. And so when we lose a proton, we go from neutral to negative. So Y is negative at a pH of 14. C terminus, so C terminus is negative at 7. If you're negative at 7, you're going to say negative at 14. Overall, the charge of ARCY at a pH of 14 is -3. So that's your answer. At 7, it's 1. At 1, it's +3. And at 14, it is +14. Any questions about how ARCY goes? Or any questions about this at all? All right, so I'm going to give you a few more minutes to do the other ones then. And since there's no questions, I will just be back in a few minutes. If you do, as always, please do ask me. But yeah, try to work on B, C, and D now. Uh-oh, frozen. That's why there's no questions. Or maybe it's just me that's frozen.